Hi everyone, thank you for the introduction. I'm Mafalda Ferreira, and today I'm going to talk to you a bit about our work, RuleKeeper, which is a system to help developers mitigate GDPR compliance violations in web applications. So, as we all know, the scale of personal data sharing and collection in web applications has been increasing significantly over the last few years. And users are often even required to blindly share their data. This, of course, raises the need to establish some data security and privacy standards, such as the GDPR. The GDPR, the General Data Protection Regulation, sets strict access control requirements on data controllers when managing the data of their customers. For example, it limits the collection of personal data only for pre-authorized purposes. Unfortunately, as we can see from the growing number of fines, such as these ones, GDPR compliance violations are still happening, and this makes users prone to numerous risks, such as the exposure of their sensitive data, and of course, the organizations themselves incur the payment of very heavy fines. It is very difficult to ensure GDPR compliance, and the process of doing so is still burdensome and error-prone. To better understand the implications of the GDPR in web applications, let's use an example. So, you are a developer, you are asked to build WebBus, a simple application to allow users to buy bus tickets. To simplify your life, you use MERN, which is a popular full-stack web framework to build your web applications. As you can see here on the right, with MERN, the front end is built with React, the server with Express and Node.js, and the database with MongoDB. How does WebBus work? So let's see an example. So Maria wants to buy a ticket to Berlin, so she will visit the WebBus website. She will check the available schedules, and as she finds a suitable one, she will buy the corresponding ticket. In this step, WebBus will collect two pieces of Maria's personal data, the name and credit card, for ticket management purposes. Before leaving the website, Maria will subscribe to the newsletter, and in this step, WebBus will collect Maria's email for marketing purposes. Even when we consider a very simple application, like WebBus, it's very difficult to ensure GDPR compliance, especially as code evolves over time. So, to give you an example, let's assume that you are now asked to implement a new marketing feature to send promo codes to frequent travelers if they subscribe to the newsletter. Here on the right, we have a snippet of the subscribe to newsletter operation in the endpoint post WebBus subscribe, and it basically consists of a database query that simply puts the email into the newsletters table. To implement this new feature, you add a new database query that will check if the users have bought more than 10 tickets in the last year. So you'll check their ticket history, and if so, you will invoke the function that sends the promo code. This is pretty straightforward. What's the problem with this query? The problem with this query is that this operation, subscribe to newsletter, is executed for marketing purposes and is now processing the user's ticket history, like Maria's ticket history, which was only authorized for ticket management purposes. So now we have data that is being processed for incompatible purposes, which we call a compliance bug. Besides compliance bugs, there are also other threats to GDPR compliance. For example, we have purpose escalation attacks. In this type of attacks, an attacker exploits a security vulnerability, for example, through an SQL injection, and has access to data that should be inaccessible for the purpose associated with the vulnerable function. There are also consent violations where the user's consent preferences are not respected. And so our goal here with this work is to help developers mitigate these GDPR compliance violations when building their web applications. For this reason, we built RuleKeeper. RuleKeeper is a system to mitigate these GDPR compliance violations in web applications by design. We built a prototype for the MERN framework, the one that I showed you in the example. And when building RuleKeeper, we focused on 3 main properties. So we wanted our system to be expressive, to be able to accommodate the different application scenarios. We wanted it to be easy to maintain, so detaching as much as possible the policy enforcement code from the application code, and of course with acceptable overheads. How does RuleKeeper work? So here we have our WebBuzz application. First, RuleKeeper has an offline phase. In this phase, the developer will write a GDPR policy using a domain-specific language. And then we have a static analysis tool that will look for inconsistencies between the application and the policy. In this phase, the developer could have specified that, for example, the subscribe to newsletter operation was executed for marketing purposes, and then the static analysis tool would detect the bug that I showed you before. When this validation step passes, the policy is loaded into the online phase, into the runtime components, where RuleKeeper will perform consent management validations in real time. In sum, RuleKeeper includes a policy specification language and employs a combination of static and dynamic analysis to enforce policy compliance. The first question that we had was, how can we specify these GDPR requirements? So, on one hand, we have the application-specific components, such as data tables and the API, which are entirely agnostic to the GDPR. And on the other hand, we have the GDPR-specific components. We have personal data, we have purposes, we have consent, we have personal data that is only collected for specific purposes. So we have here a semantic gap that we narrow by writing the policies using a simple DSL in a way that it's still easy to manage by developers. With this DSL, we can specify things like which data is considered to be personal, for which purposes it is collected, and for which purposes each operation should be executed for. After, we have our static analysis phase, and this phase is very important because first, it preemptively identifies GDPR violations that otherwise would only be detected at runtime, and it can also be used as a debugging tool to help developers reason about the privacy implications of their code. In this phase, we generate a model of the web application, which we call the data processing graph. And this graph basically models the operations that exist in the application and the data that is being processed within which operation. Then we use, we look for inconsistencies and check if those data accesses are legal by comparing them to their specification in the policy. For the other types of violations that I talked to you before, we have the dynamic phase, which I invite you to read about in the paper. For the evaluation of our system, we focused on 3 questions. So the first one is if RuleKeeper was fit to real-world scenarios. The second one was how it affected the application's performance. And the last one is if it was actually easy to be used by application developers. Here I'll cover 1 and 3. The second is covered in the paper along with the security analysis. So for the first question, we conducted 4 case studies. For the first case study, we collaborated with the clinical analysis laboratory where they give us access to their extensive privacy documentation, and we built a prototype application. And we also evaluated 3 open source web applications. Our DSL was able to cover the GDPR guidelines in scope, and we were also able to integrate RuleKeeper with few lines of code. And this showed the potential of RuleKeeper to fit to real-world scenarios. For the third question, if RuleKeeper was easy to be used by developers, we conducted a usability study with 10 participants with no prior GDPR knowledge, and we asked them to perform 2 tasks. We asked them to first specify a policy using our DSL, and we also asked them to debug an inconsistency using our static analysis tool. All of them completed both tasks within reasonable time, as we can see here from the plots on the right. And all of them but one fully specified the GDPR policy. The one that wasn't able to fully specify the GDPR policy forgot to mark one piece of data as personal. To answer the question, we received some positive feedback, and the participants underlined the RuleKeeper's usefulness as a debugging tool. To conclude, I presented you our system, RuleKeeper, a system to help developers mitigate GDPR compliance violations in web applications. RuleKeeper includes a policy specification language and employs a combination of static and dynamic analysis, and it can prevent several GDPR compliance violations with acceptable overheads. Thank you for listening, and I'm open to any question.
Thank you very much. Questions?
Yeah, this is super interesting. Is it possible to use some of your compiling, and instead of having to get into the back end, but to do something like that in the browser in the front end without having to have the cooperation? Does that make sense?
I'm not sure if I understand the question. Like using, for example, the static analysis part for the browser?
Correct. So you've defined these rules, right, where you've categorized where they can't mix together. Is it possible to tag all of that stuff in the front end of the browser without having to have access? So it's almost like you can catch the people who are violating it if you were to collect all this data in the user's browser. So if I were to install your tools in my browser and I could say, hey, here's my email, but I didn't consent to this, and without having to get into their back end to see what the query is. Have you thought about being able to do that?
Oh, that's a very nice question. I think so. Here we have access to the back end of the code, and so we are trying to help the other side, the developers. But I mean, here we are focused on, for example, database queries. So in the browser, we could not know how data is being processed, but for sure we could look for other patterns that were in the browser's codes and inform users how their data was being collected and allow them to specify their consent preferences.
Thanks for the nice talk. I have a question along a similar vein, but from the perspective of the web developer. You implemented your prototype as a tool at the web framework level. So as an extension to a web framework that controls all parts of the stack. And I'm just curious what the decision making was for why to do that, as opposed to focus on a subset of the stack.
Well, one of the things that we need to do is to map the operations that exist within the code, and for that we need to search for certain patterns. We looked for recent surveys like the Stack Overflow survey and the GitHub survey to check what were the most popular frameworks that developers were using, and we focus on those patterns to be able to model the web application, but we could have chosen another one.
Thanks.
Hi, thank you for a great talk. I'm Doug from University of Michigan. So I have a question. how do you know the purposes of one function? So for example, the same function can be used for different purposes, like send email can be used for sending promotion, but can be used to notify the user of some anomaly in the access of the users. And also when developers specify the purpose of one function, today it is for one purpose, but maybe the purpose may be changed tomorrow, then how can you address that?
I didn't understand the second question, but for the first question, we assume that an operation is executed for a single purpose, and otherwise the developer could say that an operation is executed for all the purposes, and so this wouldn't have any significant meaning for the privacy of the users. But can you repeat the second?
So then does the developer need to specify the purposes of each function by annotate each function?
Each operation, so each endpoint, yes.
Right, because multiple timeline library function, we use it for multiple purposes. So I just wonder, maybe currently you just assume one function is used for one purpose, right?
No, we assume that each endpoint, each route, consists of an operation that is executed for a single purpose.
Okay, thank you very much.
Great. Thanks very much, Mafalda.
Thank you.